So this is lesson 2, negative exponents, product and power theorems for exponents and circle relationships in algebra 2. And as you already know, whenever you have an exponent like that, that means 2 times 2 times 2. Now when you have a negative exponent like that, what do you multiply 2 by and how many times? It's impossible. You cannot expand an exponent when it is negative. You have to make it positive first. And the thing to be aware of is that negative exponent does not really mean anything as far as negativity is concerned. It has to do with place value. What that negative exponent means is that my 2 and my 3 are in the wrong place. So 2 to the negative 3 actually means 1 over 2 cubed. It means it's not in the numerator position. Actually, it needs to go in the denominator, and when we move it to its rightful place, the negative sign comes off. If I have 2 over 3 to the 4th power, and let's put a negative here on that 3 to the negative 4th power, it means that 3 and that 4 are in the wrong place. So in order to make that exponent positive, we have to move it up to its right place and put nothing down there. If we were to, for example, put some negatives kind of all over the place, and we were to have something like x times x to the negative 3 y over y to the negative 3x squared, and I were to ask you to rewrite that so that all the exponents were positive. What I would do is I would take this and move it down, and this and move it up, so it would look like this. My first x would stay where it is. My y would stay where it is because those both don't have any negative exponents on them. This y, because it's negative, would come up, and the negative would go away. And on the bottom, my x squared that's right here would stay the same, but this one would now come down to the bottom. Now they're all positive. So now all of my variables, my x's and my y's and my exponents that had negatives on them, are now in the correct place because they turned to positive. So whenever they're positives, that means we've put them in the correct place. Now we don't have to put them in the correct place in order to do our algebra, but sometimes it makes it easier, and I'll show you how to do it later on, where we don't move them to the correct place and we let the negative symbol just go ahead and stay on and work with them from there. But if you look at the top of page 127, we have 1 over 3 to the negative 2. And in order to simplify that, or to make that exponent right here positive, we put it on top, and that becomes 9. When we have 3 to the negative 3, that means that 3 and the cubed are in the wrong place. So that means we move them down and make that 1 over 3 times 3 times 3 is 27. If we have a negative 3 to the negative 2 power, that negative 2 is only on that 3. It's not on the negative at all. So what we're going to do is we're going to leave the negative there. We're going to take the 3 and move it with the 2 down below, which means it's not negative anymore because now it's in the correct place. So all we did was took this and moved the position of the 3 and the squared to the denominator place so that we could get rid of the negative, and that now becomes 1 over 9. Now part D says we've got a negative 3 in the parenthesis. So what we're going to do here is we're going to move the whole thing down. So that's going to be negative 3, and that becomes a positive 2 because now it's in the correct place. 1 over negative 3 times negative 3 is a positive 9, and we get that. So see the difference between that and that because of the parenthesis. And lastly, negative 3 to the negative 3. So what we're going to do again is we're going to take that and move it to the correct place because of that negative sign. This negative is going to follow down, and we're going to have 1 over negative 3, and now it's going to be a positive 3 there. And so there we get 1 over negative 3 times negative 3 is positive 9 times negative 3 would be negative 27. And because we have two negatives, it becomes a positive 1 over 27. So rather than dealing with theory, and I'm sure you've already done this, we're going to look at some things like x squared times x cubed. And what this is called the product theorem for exponents. Whenever we have letters or numbers that are the same and they have exponents and we are multiplying them, that is the same as x to the 2 plus 3, which is x to the 5th. Now the reason that works is because x times x would be our x squared, and our x cubed would be right there. How many x's do we have? We have 5. So that's why it works. So when the x's, or even if it's 3 squared times 3 to the 4th, that equals 3 to the 2 plus 4, which is 3 to the 6. Now if this were 3 squared times 4 squared, you can't do this because we can't, our base numbers are different, so we can't follow the same method. So it only works when the letters or the numbers are the same when they're in the base position. So if we have something as complicated as x squared y, x to the negative 5, y to the negative 4, x to the 5th, something like that, we're going to get all of our x's and we're going to write them like that. We're going to put all of our exponents together. And then we're going to do the same with the y's. This y here is an assumed 1 when there's nothing up there, so we'll have a 1. And then we have a negative 4. So we can combine these, and we get 2 minus 5 is negative 3, plus 5 is 2. And 1 minus 4 is negative 3. And we're done there, unless they say we want all the exponents to be positive. Therefore, that's in the wrong position. So we're going to rewrite it by putting it in its opposite place, and we can take the negative sign off, and we get x squared over y cubed. And sometimes that's necessary. Sometimes they want you to do that. So this is example 2.3, and they're asking us to simplify. So we're going to put all the x's and y's together. We're going to look at the numerator first. So we'll put x, we have an x to the 4th, and an x to the minus 10. And that takes care of that one and that one. And then for our y's, we have a y, we have a 1, that's right there. We have a minus 3, and we have a plus 5. And that gets rid of our y's. Now we're going to look at the bottom, and we'll do our x's. I have an x to the minus 3 and an x squared, so I'll do that, and then I can cross these off. And then I've got a y to the negative 6, and I have a positive 10, and I can cross those off. So let's combine. X to the 4 minus 10 is negative 6. Y, 1 minus 3 is negative 2, plus 5 is a 3. X, negative 3 plus 2 is a negative 1. And y, negative 6 plus 10 is a positive 4. Now, you could leave it like that if they don't care, if they don't ask you to do anything, but sometimes they'll say, we want our answer with all the numbers in the numerator position. We don't want any numbers down here. If that's the case, then we move them up. We take this and move it up. And when we move it up, that negative now becomes a positive. So we've got x to the negative 6, and then x, we move the x to the negative 1 up, and it becomes a positive. Our y cubed stays there. Y to the positive 4 means it's in the right position. So when we put it in the wrong position, we have to put a negative there to say it's in the wrong position, but we're going to put it there anyway. Okay, therefore, that becomes a little bit closer where everything's in the numerator, but now we're going to combine our x's, negative 6 plus 1, and we're going to combine our y's, 3 minus 4. And that's with everything in the numerator position.